Welcome to the webinar, Master the Destiny of Your Alarm System with a Master Alarm Database. My name is Todd Stauffer. I'm the Director of Alarm Management here at Exida, a company that's focused on making the world a safer place, primarily process plants. We provide services in the area of process safety, cybersecurity, alarm management. We do certifications of devices and people, and we also have a tool set for designing safety instrumented systems. Included in that suite of tools is one for alarm management called Alarm, which is one that we'll talk about a little bit during today's webinar. So speaking of today's webinar, what we're going to focus on is the concept of a master alarm database. And we'll talk about what it is, how you create one, what information should be included in one or could be included in one, how you use it to document the results of rationalization, how you can use it also to create alarm response procedures, how you might integrate it into your management of change process, how you might use it to update the configuration of your control system. And we'll also talk about some selected key features and best practices related to the design of a master alarm database. So we'll start with a little look at some of the famous masters throughout history, including the Dutch masters, put in here for one of my Dutch colleagues. We also have maybe the most famous one, Yoda from Star Wars, the Lego guy, and the Masters golf tournament here in the US. So what we're going to add to this is the concept of a master alarm database, abbreviated as MADB. This term was introduced in the ISA-18.2 Alarm Management Standard, which came out in 2009. It's also contained in the international version of that alarm management standard called IEC 62682. And it's defined as the authorized list of rationalized alarms and associated attributes. So we're going to take a look at what that means in a little bit more detail. So if you've ever heard of a master alarm database before, or you've never heard of one, you may have heard different terms used to describe a similar thing. In the past, these similar terms that have been used include an alarm table, alarm response manual, variable table. This is just a short list of some of the similar terms. One of the benefits of standards is to establish a standard set of terminology that everybody can use. So one of the benefits of the two standards I mentioned is coining this term, master alarm database, and basically promulgating that in industry and suggesting that that be used from now on to refer to these type of entities. Now, when it comes to the format of a master alarm database, there are no requirements for it per se. It could be a piece of paper. It could be the back of a napkin, although that would not be a good implementation. Really, it should be an electronic file, a database of some sort. It could be Microsoft Excel, could be Access, or it could be actually a built-for-purpose tool that's specifically designed to house alarm management information. There are many of these on the market. One of them is a tool that Exida has called Alarm, and some of the examples that we'll talk about today come from that tool. So looking again at the definition of a master alarm database, it's for documenting information about alarms. So what is an alarm, or what do we mean by an alarm? In the context of the standards, an alarm has a specific meaning, and it's supposed to be used for a specific thing. It's supposed to indicate an audible and or visual means of indicating to the operator an equipment malfunction, process deviation, or other abnormal condition requiring a timely response. The word timely has actually just been added newly in the IEC standard to the definition of an alarm. Part of the idea with this definition is so we can optimize the performance of our alarm systems and make sure that operators only get these things that we categorize as alarms. Alarm performance problems come into play when they get things that are called alarms but don't really meet this strict definition or this strict criteria. The process of reviewing the alarms that you have or that you propose to have to make sure that they meet the criteria for being an alarm, such as this definition here, is the process called alarm rationalization, which is one of the stages of the alarm management life cycle, which is defined again in both of the standards, the ISA and the IEC standard. The rationalization then is a process where you review either your existing alarms that you already have or ones that you think that you need to compare them against the criteria that you've established for an alarm. And that would be documented in your alarm philosophy document. It would contain information like the definition that we just looked at, essentially making sure that your alarms meet that definition and maybe more. We would also define the value of the attributes of the alarm. I'll talk a little bit more about what that means. But what we're referring to is things like the alarm limit, its priority, maybe its classification. Other parts of the rationalization process then include what the alarm means or what its purpose is. Things like what would likely cause the alarm to occur, what would be the consequence if the operator didn't respond to the alarm, and what is it that the operator should do when the alarm occurs. And all this information, result of rationalization, is to be documented in the master alarm database. So let's look at what an attribute is, an alarm attribute, just to complete the look at the definition. So if we think about an alarm, and let's say we're looking at a high level alarm, it has attributes, or it has parameters that go with it. Here we can see the definition that comes out of the standard. But what we're basically saying is that alarm has some characteristics that go with it, including things like the limit or the priority. Other settings include maybe the deadband or the hysteresis. There might be a message that goes with the alarm. There's the characteristic of whether the alarm is enabled or disabled. There's on delays and off delays. So there's a lot of parameters that can be associated with the alarm and help to fully characterize its configuration or its design. So now let's think about what information or what attributes should be in a master alarm database. And to start off that discussion, let's look at what's expected to be recorded as a result of rationalization. And for that guidance, we'll look at the standards again. The IEC standard builds on the ISA, and in this case you can see that it's added one additional term, the probable cause. So at the bottom we've defined essentially the minimum set of information that's expected to be defined during rationalization. So that sets the starting point of what we need to document in the master alarm database. Things like the priority, the class, the alarm set point is the term we use, also known as alarm limit, and you can see the other terms there. Now, if we expand that to what else would likely be included to complement that set, we're looking at things like the tag or the tag number, which is the way you would identify the instance of the alarm, perhaps the tag description, maybe the response time as well. So those are things that you would typically see to go along with what we saw coming out of the standard. Now then there's other elements that would be potentially recommended to include in your master alarm database. Some that relate to the configuration in the control system, things like the engineering units or the engineering range, the location of where that alarm occurs within the control system, the alarm deadband, whether it's got an on or off delay, essentially parameters that are configurable within the DCS. Then there's other ones that relate to documenting additional background information for the decision making during the rationalization process, such as when you come up with what the alarm limit should be, how did you establish that? What's the basis of the alarm set point? Maybe the same for the alarm priority. When you've established that, how did you come up with that? So these recommended fields come in two flavors. Again, the ones related to the configuration in the control system, and that's optional. Some of these fields, like the on delay and off delay and deadband, strictly speaking, are not part of the rationalization process, so they don't necessarily have to be part of the master alarm database. However, if you want to completely characterize the configuration from your control system, you might want to include those parameters. Going beyond that, then, there's additional information that might be different from user to user or situation to situation, project to project. So if what we looked at on the previous slide was kind of the standard set of commonly expected alarm elements and terms, there might also be a set of information that would be specific to a certain customer or certain project. And you should allow for that information to be documented in the master alarm database as well. So for example, the alarm limit or the alarm set point, going a bit further and establishing the basis for that. Typically the alarm limit is set to prevent your process variable from getting to a certain point. Well, what is that point? What is the consequence that occurs when it gets to that point? So defining what those constraints are, where you don't want the process variable to get to, is critical or very important in effectively establishing the alarm limit. So defining information like your safe operating limit or your design constraints or relief valve trip points or SIS trip point relief valve lift points, lift settings, SIS or interlock trip points, all that is very good information to incorporate into the master alarm database to substantiate the establishment of alarm limits. Going a bit further, you might want to, in more detail for each particular alarm, establish what the corresponding consequence or normal operating limit is, the consequence threshold, which is the point where you're trying to put the alarm in there to prevent the process from getting to that point. So there's a lot of value-added information that can go in your master alarm database, and typically you should allow for this kind of customization from, like I said, user to user or project to project. We build that in as a standard capability within our SIL alarm tool, allowing you to define 12 fields to be used for whatever purpose is necessary, and also allowing you to have those fields displayed in the context of the rationalization process where it might make sense. So if we were looking at recording information that provides additional information around the alarm set point, then we might want that information to appear when we are reviewing the alarm set point. So we can set that up to occur in the SIL alarm tool. So that's the attributes and the information, the structure of the master alarm database. Now, where do the alarms come from that we want to put into this master alarm database? It really depends on whether this is an existing running control system or a brownfield installation, or whether it's a new system, a greenfield. Certainly, if it's an existing control system, the best place to start is to extract the actual alarms that exist in the control system. Maybe the ones that are configured and not configured yet, but all of the alarms that exist in the control system. If it's a greenfield or a new system, you're going to primarily be looking for alarms defined in other sources like PNIDs or PHA studies or HAZOPs or LOPAs or operating procedures. These may all call out the need for alarms, which we would take that information and then load that into our master alarm database so that it's ready for the rationalization process. This loading or selection of potential alarms is called the identification stage of the alarm management lifecycle. So how do we actually create that master alarm database then? Pretty much it depends on whether it's, again, an existing control system where we want to suck out essentially the actual alarms that are already configured in the control system, or if it's a greenfield, it's a new project, then we're going to be looking at the different sets of project documentation that exist that may define the potential need for an alarm and use that to create our initial master alarm database. Then we're ready for the rationalization process, which is the ultimate goal of the master alarm database, is to effectively document the results of the rationalization process. So we'll take a quick look at some of the steps that are included in that, such as first starting off with determining whether the alarm is valid or not, judging against the criteria from our alarm philosophy document, and documenting things like what's the expected operator response, or what's the consequence if the operator doesn't respond. That helps us even determine whether the alarm is needed or valid or not. Documenting that, we'll see later on that we can use that for informational purposes. But these are key pieces of information that should be documented in the master alarm database. A next step in the rationalization process is defining the priority of an alarm. Typically, priority is set, and the priority is what the operator relies on to know which alarm to respond to first. So it's a measure of the relative criticality of one alarm judged against another. Typically, alarms are prioritized based on looking at the potential consequences. If the operator didn't respond, what would happen, and the amount of time available for the operator to respond. A common method uses a matrix similar to this, where we have a set of consequences here defined at the top in 3 different impact areas as an example. So for a given alarm, we would assess the potential consequences in the area of personnel, environmental, and financial. We would take the worst case consequence from that. Perhaps it would be a financial consequence. Maybe there's no environmental and no personnel impact. We would couple that with an estimate of how much time the operator has to respond. Let's say 5 to 15 minutes. And the combination of those two dictates what the priority should be. So in a well-structured master alarm database, one might want to define and record all of this information so that you're not just defining what the priority is, but defining the steps for how you got there. In other words, what were the consequence rankings and your predicted amount of time to respond, and help justify how you came up with the priority. In some cases, you won't use the priority matrix to define the priority. You might assign it based on rules from your alarm philosophy. Like maybe it's an alarm for a gas detector or something that relates to personnel safety, where you can say, oh, we already know that's going to be the highest priority. So let's set that within the master alarm database, and maybe we document why we did that. Why didn't we use the matrix? In this case, we did it because that's part of our philosophy, so we documented the reason why. Another part of the rationalization process is defining or assigning alarm classes to the alarm, the process of classification, which is done to help organize alarms that have common sets of requirements for training or testing or management of change, for example. If you think about all the alarms that exist in a process plant, they're not all created equally. They don't all have the same importance. They don't all have the same level of attention paid to them. For example, that gas detector alarm or the low oxygen sensor or the H2S sensor that all relate to personnel safety, they're probably tested on a weekly basis. You don't test every alarm on a weekly basis, so there must be something special about those. Well, the special relates to how they impact personnel safety. So there you have the origin of classification, to be able to group those alarms that have that different set of requirements, in that case for testing. So we want to be able to document that within the master alarm database. Alarms can be assigned to one or more classes. In many cases, the classification process relates to whether the alarm is used for safety purposes. So as part of the classification process, you might also want to document whether the alarm is a safeguard from a PHA or a HAZOP, and whether it's used as the independent protection layer, which would help you essentially create a cross-reference in the master alarm database between your given alarm and the safety design studies that have called for the need for that alarm. And there's many customers in the oil and gas market that require that kind of a cross-reference in their master alarm database. So any alarm that's used for safety purposes or safety risk, for risk management or risk mitigation, they want to have that cross-reference to where that alarm is called for in the associated safety design study. Next step in the rationalization process is defining or reviewing the alarm limit. And again, we talked about defining not just the value that you set the limit at, but how you came up with that, how you got there, whether it relates to your constraints and process dynamic information that you know, or how much time the operator needs to be able to respond. All of that information is relevant for when you engineer what the limit should be. So what's recommended then is to not just define the limit, but also document why or how you got there. Maybe the interim calculations, or for sure the basis or the rationale for why you set the limit where you did. So that in case the limit is challenged later on, perhaps you have changes in your process and the limit does in fact need to be changed. Now you could go back and look at why the limit was set where it was, looking into the master alarm database, and hopefully be able to assess whether it's appropriate to change the limit given maybe new process characteristics. Master alarm database, again, might also include some information about alarm deadbands and on-off delays. These are parameters that help to eliminate nuisance alarms. Strictly speaking, as I said, they're not part of the rationalization process, but they are configurable parameters in the control system typically. So if you want your master alarm database to completely represent all of the configuration of the alarm, then you would want to include these pieces of data in your master alarm database as well. And then the last part of the rationalization process is typically to define whether there's any requirements for suppression. One type of suppression is called shelving, which is when the operator temporarily suppresses the alarm. So one potential thing to do in the master alarm database is document whether that alarm is allowed to be suppressed and perhaps how long it can be suppressed for. In addition, there may be scenarios where the alarm actually needs to have a different limit or a priority depending upon the state of the process. If you were just starting up a process, or you were shutting it down, or it's running at 50% capacity, there's key things that you probably want to have at a different alarm limit or have a different limit set to reflect that non-normal operating mode. So that's another key element of what you might want to document in your master alarm database. You can take that a step further and say that in some cases during those states, maybe when you're starting up or you're shutting down or the unit is offline, instead of having a different limit, you actually want to just entirely suppress the alarm. So the master alarm database should also be able to capture your design suppression requirements. That is, we want the alarm to be suppressed under these circumstances. Could be when equipment is offline. It could be in the event of a transitory situation, such as a trip of a compressor, that you would define a specific grouping of alarms that should be suppressed under those circumstances. So you can capture those requirements in your master alarm database. And hopefully you can start to see that as your process and your alarming requirements or needs get more complex or more complicated, that the design or requirements for your master alarm database also become more complicated. So if you have a small, very simple system with maybe 100 or 200 alarms, you might very well be able to make do with a homemade Excel spreadsheet. However, if you have a complicated process with 10,000 alarms and different operating modes and suppression scenarios, that's when the built-for-purpose tools really show their stuff, really come into play. Now, we're going to switch gears to something called alarm response procedures, which is something that's called out in both of the standards as well. And this is actually something that's a requirement. So people are supposed to be doing this. You're supposed to be providing alarm response procedures to your operators to help them know how they should respond to an alarm. Now, it doesn't, the standards don't dictate the format of how to do that, but they do talk about some of the information that should be in there, and we'll look at that in a second. But if you thought about, if you were in the operator's shoes and a new alarm came in, what would you want to know? You would want to know what the priority of the alarm. You'd also want to know, hey, what just happened to cause this alarm to show up? What am I supposed to do? What's my expected response? What's going to happen if I don't respond? And how much time do I have to respond? Those are, key things that you would like to see to help you be able to respond to that alarm effectively. The ISA standard and the IEC standard actually define the information that should be in an alarm response procedure, and you can see here it's information like that. The alarm set point, the potential causes, the consequence, the corrective action, how much time. Well, if you remember when we talked about alarm rationalization and the requirements for that, these fields are almost identical. So it's essentially the information that you're supposed to document as part of rationalization is also the same information that you should be making available to the operator in the form of an alarm response procedure. So a dual purpose of the master alarm database is not just to contain all this information when you're done, but to be able to extract it out and create these alarm response procedures. If you're not doing that, then you're not getting the full benefit of performing the rationalization process. So with our cell alarm tool, we can actually create alarm response procedures as self-contained documents from within the tool. We can also pass the information into the control system, and if it has its own system for presenting alarm response procedures or alarm help, it can do it that way. So we support both of those. So now let's shift gears and talk about maybe some of the other key features that would go into a master alarm database to make it as effective as possible. And we'll talk about connecting to the control system. We'll talk about filtering the database depending upon the size. We'll talk about extracting the information from the control system in reports. and copying alarm information from one alarm to another, bulk rationalization. Then we'll also talk about how we incorporate the master alarm database into our management of change process, including auditing to make sure that there aren't unauthorized changes made to the control system to make it deviate from the master alarm database. So when you're thinking about an effective master alarm database, again, its purpose and its life doesn't stop with the collection of the alarm information. In fact, the real benefit comes from when you take that information and put it into your control system. So information like the alarm limit or the priority or the message or the on delay or off delay, those parameters, those attributes might be changed as a result of your rationalization process. So you want to get that into your control system so you can have the benefit of what you've just done. You don't get the benefit of rationalization until you move the configuration changes into the control system. Well, if it's just a standalone Excel spreadsheet, there may not be a very good way to get the information out and get it back into the control system, and you may have to make your changes as a onesie-twosie process manually. But hopefully with the creation of your master alarm database or the use of a built-for-purpose tool, there's a way to automate that process so that the necessary configuration changes resulting from rationalization can take place automatically. So that's a key thing to look at within the structure of your master alarm database, getting the information out of it and using it to update the control system. And how long does that take? Certainly if it's an automated process, that reduces engineering hours, which saves time and money. So that's all part of the equation that one would need to look at. Other ways to get the information out and other ways to present it, besides taking it directly into the control system to update the configuration, you might also want to represent the information in certain forms, certain reports or specifications that help to kind of document what the design is or the results of rationalization. So a good master alarm database tool would also have a way to extract and present in custom reports or standard reports a certain way to represent that information. So whether it's the design of an alarm flood suppression scheme or all of the alarm settings associated with a certain control module, there should be a way to group that information together to make it easier to understand. In addition, as the size of your control system or your number of alarms gets bigger and bigger, that makes it more challenging and more taxing on the master alarm database. And that's when the use of a tool like Excel might run its course and it's time to move on to something more sophisticated like a built-for-purpose tool. So if you've got an alarm system that's got 10,000 or 20,000 alarms, the ability to be able to filter and focus in on a certain relevant subset of alarms, maybe all the alarms from a certain PNID, or all the alarms from a certain process area, or the alarms that are upstream and downstream of a certain piece of equipment. The ability to focus in on that really helps and expedites the rationalization process so that you can do it all in the context of a unit or a process rather than one alarm at a time. So being able to filter that master alarm database for the purposes of creating good logical groupings is very important. Here's some examples of the capabilities that might be provided there, including in this case the ability to create a custom filter basically formed from any of the parameters in the master alarm database to define exactly what alarms are displayed in the context of the tool so that they can be operated on or rationalized or have bulk engineering or bulk rationalization performed on them. So again, with the ability to filter, powerful filtering capability also gives you the ability to pinpoint and isolate changes, such as if you've got a bunch of alarms that are all very similar to each other, being able to filter within your master alarm database would allow you to set up one alarm from which you've completed rationalization for and effectively copy the information, copy the rationalization results, copy the alarm settings, the limit, the priority, the cause, consequence, whatever would be the same, to a whole bunch of other alarms that might be similar, maybe similar pieces of equipment from different units. So the filtering allows you to be able to effectively and safely copy information from groups of alarms to other groups of alarms, thereby reducing the amount of time it takes to do the rationalization. Now let's talk about your management of change process and integrating the master alarm database into it. Now, given the fact that what we're talking about is the master alarm database, the idea is essentially that that would be the single repository for your alarm settings and configuration and would dictate to everything else what those settings should be. So one might assume then that any potential changes to an alarm setting, once they've gone through management of change and been approved, should probably be implemented in the master alarm database first and then pushed into the control system or implemented in the control system next. Well, in a lot of real-life scenarios, that's not practical, or that doesn't support the operation. In some cases, if there's a change that's needed, it's to support an operation, and that needs to be done immediately and in the control system first. So if that's the way your management of change would dictate changes are done, then there needs to be, as part of that process, a way to synchronize those changes and get them into the master alarm database so that it always reflects, again, what's expected of the settings to be in the control system. So even if your process is to make the changes in the control system based on MOC, you got to be able to make sure that those are then quickly updated within the master alarm database. Now, one way to help support that process and keep track of the status of which alarms have gone through rationalization and which ones you have to be concerned about changes to is, again, for the master alarm database to be able to track your progress for each alarm. So for each alarm, perhaps having the ability to say that the alarm is ready to be approved. You know, maybe you've completed rationalization and you have a 4 eyes policy and somebody else needs to look at the results and approve it. So you can keep track of it that way. And then maybe once it's completed that, it goes into the approved state, and then once it's pushed into the control system, it's now a configured and rationalized alarm. So a good master alarm database helps you keep track of the status, the rationalization status of your alarms. Because certainly if you have a really big system, 10,000, 20,000 alarms, your rationalization process is not going to be completed overnight. That could take months, easily take months. So to be able to track your progress and the status is pretty important. Now, in conjunction with the management of change process, we want to perform audits every so often. Again, that's another stage of the alarm management lifecycle, to periodically assess the processes that are being used, including what's recommended is comparing the values that are in your master alarm database to what's actually running in your DCS or other data source. So, and what you're ideally looking for or hoping for is that there really aren't any changes. And that all depends, I guess, on what your management of change processes are and what your operators are allowed to freely change from the HMI. If that is a relatively locked down environment and operators are not allowed to change things without an MOC process, then you would hope that there would not be significant discrepancies between the actual settings in the control system versus what you believe that they should be in the master alarm database that resulted from rationalization. However, depending upon your scenario, you may find a few to significant numbers of changes. So as part of the audit process, that gives you the opportunity to again synchronize the configuration to the master alarm database. And you want to potentially look at each individual change to consider whether it's a relevant or appropriate change, an appropriate difference, where the new value maybe should be pushed into the master alarm database. Maybe it's a more recent and appropriate value. So you want to look at each individual change to make an assessment as to how it should be processed. And typically what would be recommended is to think about whether the change should be rejected, whether it should be accepted or approved, or set to enforcement or to be enforced, which essentially means you want that value or that parameter of the alarm to be reset in the control system back to what it's supposed to be as defined in the master alarm database. So we're talking about a lot of advanced functionality around this, what we thought was just a simple database of alarm information. So certainly, again, the ability to be able to take the information that's in that master alarm database and use that to compare to what's actually running, whether it's changes to alarms or new alarms or removed alarms, is pretty important as part of the alarm management lifecycle. And as I mentioned, the ability then to designate certain changes as those that need to be enforced or need to be reset is also an important capability. So now we're kind of reaching the end of the webinar, the presentation. So just to kind of summarize what the master alarm database is, it's the authorized list of rationalized alarms and their associated attributes, information that's populated from either the control system configuration or various data sources. That information, once rationalization is complete, the master alarm database can be used for design documentation. It can be used to update the control system configuration. It can be used to create alarm response procedures. It should be used to audit periodically the configuration that's running in the control system to maintain the integrity essentially of the system, and that it's running with the settings that it should be or that you expect it to be. So again, summary of what a master alarm database is: rationalized alarms, documenting the results of rationalization, and some of the best practices and considerations that would help make the master alarm database more useful. Things like being able to create alarm response procedures from those results, being able to connect to the control system and automatically update the control system configuration based on the results from rationalization that are stored in the master alarm database, filtering capability to allow you to home in on a group of alarms to perform rationalization for, to expedite that process and to make it easier to copy rationalization results from one alarm to other alarms that are similar. We talked about how to integrate the master alarm database into the management of change process, so it's not a static database that's used initially just for development. It's really a critical part of your alarm system and maintaining it over the life of the control system. So it should be part of your management of change process. And to support that management of change process, it's recommended to do comparisons every so often of what's in your master alarm database, the settings there versus what's running in your control system. So hopefully you found this webinar to be useful and informative. I would thank you for your attendance, and also suggest that if you're interested in learning more about the topic of alarm management, please feel free to check out some of the other webinars that we've had in the past that are recorded and available for viewing at your leisure. I have my email address listed at the bottom of the slide. Certainly if you have any questions on this presentation or alarm management in general, please feel free to shoot me an email message. And again, I want to say thank you for attending this webinar. I hope you found it useful, and I hope you can join exida for future webinars as well. And on that note, I will look to see whether there's any questions that have been defined. I don't see any right now, so what we'll do is we'll end the session, and if any questions do come in, I will answer them and distribute the results to everybody who attended. So once again, thank you for your time, and have a good rest of the day.